My name is Melissa Pastore, and I'm a research ecologist with the U.S. Forest Service FIA, and I'm part of the Northern Research Station, or NRS. One of my roles with FIA is supporting the Soil Monitoring Program, which is part of the NFI, or Nationwide Forest Inventory, carried out by FIA. Most people are less familiar with FIA's soil assessment than the tree assessment, so I wanted to introduce it. So looking at the program history to start, what is now the soil monitoring component of FIA's Nationwide Forest Inventory was originally the soil indicator of the Environmental Monitoring and Assessment Program, an EPA research program that developed tools for monitoring national ecological resources. The soil indicator, along with other forest health indicators, were folded into the Forest Health Monitoring, or FHM, program with its formation in the early 90s due to increasing concerns about forest health and air pollution. While FHM was conducting forest health assessments, FIA at the time was conducting forest inventories primarily to report on the trends of timber and woodland species. But after the 1998 Farm Bill, the FHM and FIA plot networks were integrated, and beginning in 2001, the soil indicator was implemented as part of the FIA Forest Ecosystem Health Indicators program within the NFI. Since that integration, a subset of FIA's standard NFI plots are designated for measuring different forest ecosystem health attributes, including soil characteristics. This means that FIA provides co-located soil, tree, and site data that allow for the exploration of relationships between above and below ground factors. Turning to the overview and design, the size of the soil subset now varies among regions, but includes at least 1/16 of the forested NFI plots for any regions that are measuring soils. Below the yellow text box here is a diagram of an FIA plot on the left and a soil sampling schematic on the right. The forest floor samples, which contain the duff and litter layers, are collected along sampling lines adjacent to subplots 2, 3, and 4, and the mineral samples are only collected adjacent to subplot 2 and include the 0 to 10 and 10 to 20 centimeter depths. The soil variables monitored are diverse and are listed here in the text box. Lab measurements include things like carbon and nitrogen concentrations, coarse fragments, pH, extractable phosphorus and sulfur, exchangeable cations, trace metals, and more. Physical properties include things like soil texture, bulk density, and the thickness of the litter and forest floor layers. So I actually want to jump over to the top right corner here to talk about data availability. So far, about 10,000 forested NFI plots have been sampled nationwide, of which about a quarter have been resampled. About 700 forested plots have been sampled in the New England region, including 86 plots in Vermont. Looking at the map, remeasurements are colored in orange and red here, so you can see that they're largely in the Northern Research Station and Rocky Mountain Research Station regions. The NRS measures 1/8 of forested NFI plots by alternating between two 1/16 subsets, and we just published soil lab data from 2012 through 2021, adding to the data that already existed through 2005, so now is a great time to explore what's available in the FIA database if you're interested in soils. Shifting back to the middle, the soil data generated so far have been used for a variety of reporting and research efforts. I included two brief case studies here as an example. The top one, highlighting how FIA's co-located above and below ground data can be leveraged to answer questions about forest health. This is an example looking at soil calcium to aluminum ratios and sugar maple health in the area that was most affected by the deposition of sulfur dioxide and nitrogen oxides in the early 2000s. We binned FIA data into an early period from 2000 to 2005 and a late period from 2012 to 2021 based on soil data availability and the interval over which nitrogen and especially sulfur deposition declined. Soil calcium to aluminum ratios increased substantially from the early to the late period, while the proportion of sugar maple crowns with high crown dieback declined by 67%, indicating that regulates to mitigate emissions and acid rain have positively influenced soil and forest health. The bottom case study demonstrates how FIA may be used to look at patterns in soil properties over time using direct field measurements. We looked at change in soil organic carbon over time using plots with SOC values for both intervals of mineral soil depth at the first and second soil measurements of the plot. So the criteria were pretty restrictive because not every plot has been remeasured and not every plot includes both depth intervals. But the ability to look at change will strengthen as more plots are revisited. But the direct measurements available to date suggest that broadleaf forests have generally gained more SOC than coniferous forests, possibly because coniferous forests may be more prone to fire and pest outbreaks, but we'll see how these patterns play out as more plots are remeasured. And then I included a note here on the bottom. FIA generates predictions of litter and soil carbon across the country. And if you've used those estimates in the past, they were produced from models based on geographic area and forest type and did not incorporate FIA's field collected soil data. But those models have been updated and are now using real FIA soil measurements. The 2019 study cited here expanded predictions from points to pixels, so we also have continuous predictions of litter and soil carbon stocks on forest land. So definitely check those papers out. They're all here at the bottom. So in conclusion, I'll mention that part of what I'm working on in my role in collaboration with others across the regions is identifying opportunities to improve and build upon FIA's soil program. I've highlighted just a few in the bottom right corner, but we'd love to hear from you about what your ideas and needs are. So feel free to get in touch, and thanks for listening.